Alright, we are continuing polynomial functions. We are looking at problem number 5. Problem number 5 asks us to state, first of all, the number of possible real zeros. So the number of possible real zeros, basically how many places could this function right here hit the x-axis. That's pretty easy. All you have to do is look at this exponent right here, this degree that's a 3. That lets you know there are 3 possible real zeros. Okay, so the possible real zeros are 3. Next thing the question asks, how many turning points, how many possible turning points of each function? So what are the possible turning points? Just remember, the possible turning points are always going to be 1 less than the amount of possible real zeros. So that's going to be 2. Now this graph is a cubic function, and not all cubic functions look like this, but basically if you have a turning point in a cubic function, this is what it's going to look like. Let's go and draw an x-axis and a y-axis. Here's an x-axis, there's a y-axis, there's your x, there's your y. If your graph comes up, it could go up, then go back down, and then go right back up. Now not all cubic functions look like this, but this right here is called a turning point. This right here is called a turning point. This right here, these points right here are your real zeros. So you could have at most 3 real zeros, and you could have at most 2 turning points. Because you could have this exact same graph, but shifted up, and it could go down like this and not quite reach, and now you'd only have 1 real zero, but you would still have 2 turning points, but it only crosses the x-axis once, whereas this one, it crossed it 3 different places. Okay? So that's what it's asking you about. Now it says, then determine all the real zeros by factoring. So you're like, okay, how do we factor this guy? Wow, looks a little intimidating. So we have f of x equals x cubed minus 3x squared minus an x plus a 3. So when you're asked to factor something that's cubic, the first thing you need to look for is common factors. So I'm going to highlight this very first part. Do you see any common factors between an x cubed and a negative 3x squared? Well, not exactly an easy thing to see, so let's break down x cubed. What is x cubed by itself? X cubed by itself is x times x times x. Now what is a negative 3x squared? What does that break down to? A negative 1 times a 3 times an x times an x. So we're looking for what's called the GCF, or the greatest common factor between this monomial and this monomial. So I'm going to highlight that. Hopefully you can see that this right here has an x squared, and this right here has an x squared. So the GCF, or the greatest common factor between x cubed and minus 3x squared, is an x squared. So I'm going to factor this out of both of those. So I'm going to factor out the x squared out of x cubed. If I factor out x squared out of x cubed, I'm just left with what? I'm just left with x. And if I factor an x squared out of a negative 3x squared, I'm left with a negative 1 times a 3, so I'm just going to put minus 3. So right now I factored out an x squared. Let's see what we have left now. We have a minus x plus 3. So we have a minus x plus a 3. Now upon first inspection you might not be able to see, but you can actually factor something out of this negative x plus 3 that will be very useful. For those of you who are really good at factoring, you probably recognize that you can actually always factor out a -1 out of a binomial expression. So if I factor out a -1 out of this, what's still left inside? An x. And if I factor out a -1 out of a +3, you're going to be left with a -3. So -1 times x is a -x. -1 times a -3 equals a +3. So how do you check your work? You check your work by using the distributive property. And you'll notice the distributive property, if you use it, will get you back to your original function. Okay. Now, x squared times x minus 3 minus 1 times x minus 3 right here. These actually now share a common factor. You'll notice that this x minus 3 and this x minus 3 are the same. So let's imagine real quick. Let's not look at this x minus 3. What if we had an x squared times an a minus 1 times an a? Well, what's the common factor between this x squared and this -1? What's the common factor? The common factor is a. So you would be allowed to factor the a out, and you're left with x squared minus 1. Well, here, what's the common factor? The difference between a number and 3. The difference between a number and 3. Those are the common factors. So I can actually factor out x minus 3, and what do I have left? I have x squared minus 1. Now, here's what we have. This function right here that originally started out as this, f of x equals x cubed, all right, minus 3x squared plus an x minus a 1. Oh, sorry. My bad. Minus x plus 3. My apologies. Minus x plus 3. Okay? These functions right here are the same function. Alright? This has just been factored more. Now we're almost done. The final answer with everything factored is x minus 3. And x squared minus 1 will factor to x plus 1 and x minus 1. Now if you didn't automatically recognize that, that means you aren't comfortable with the difference of squares. So let's write down some common difference of squares. Alright, so the difference of squares. Here's the pattern. If I have a squared minus b squared, that will always factor to a plus b and a minus b. But usually you don't see a squared minus b squared. Usually you'll see something like this. You'll see x squared minus 1. You'll see x squared minus 4. You'll see x squared minus 9. X squared minus 16, and so on and so forth. I'm just going to jump all the way down and put x squared minus 81. Okay, and there's a certain pattern to all of these. So x squared minus 1 factors to x plus 1 and x minus 1. X squared minus 4 factors to x plus 2, x minus 2. Hopefully you see the pattern now. X plus 3, x minus 3. X plus 4, x minus 4. And if we jump all the way down to this 81, you're going to have x plus 9, x minus 9. Right? So this is the pattern for difference of squares. Okay? So what if I said, what is a squared x to the 4th minus b to the 6th d to the 8th? What would that factor to? That would factor to a x squared plus b to the 3rd d to the 4th, and then a x squared minus b to the third, d to the fourth. Alright, basically all you do is you're taking the square root of this, taking the square root of this, and putting a plus and a minus. So that's why when we looked over here, I realized that x squared minus 1 factors to x plus 1 and x minus 1. You need to know the difference of squares. So this is our final function, totally 100% completely factored. Now what are my real zeros? My real zeros, right here, what number minus 3 gets me to 0? 3. What number plus 1 gets me to 0? Negative 1. And what number minus 1 gets me to 0? Positive 1. So my final answers for my solution set are a negative 1, positive 1, and a 3. Now we didn't use the graphing calculator at all. Alright, we just factored this by hand. But what I want us to do right now is I want us to go to the graphing calculator. We're going to type in this original function right here. We're going to type it in. Alright? Remember, the original function was x cubed minus 3x squared minus x plus 3. That was the original function. So I'm going to go ahead and do that. Go y equals. Go x cubed minus 3x squared minus x plus 3. And I'm going to hit, nope, not. There we go. So there's our function right there. Okay. Now the first thing we did was we factored out the x squared. So we said it was x squared parentheses x minus 3. And then we factored out a negative 1. So I said minus 1 parentheses x minus 3. So that was our next. That was the next thing we did. We factored out an x squared out of this front part, and we factored out a negative 1 out of the back part. Now watch what happens when we hit graph. Same graph, which means it's the same function, we just factored it. Now if we go down here and type in x squared, oh, got to do it in parentheses, sorry. Second delete allows me to insert something. I'm going to insert, there we go, a parentheses. If I say x squared minus 1 parentheses, open parentheses, x minus 3, here I have an x squared minus a 1 times an x minus 3. If I hit graph, you'll see a trace. Same function. And finally, last but not least, if I break this one down and I say, alright, we have an x plus 1 and an x minus 1 and an x minus 3. Then I hit graph. Once again, you see the exact same function. And look, where are all the zeros, everybody? The zeros are located where? At a negative 1, at a positive 1, at a 3. And hopefully you realize that this is just a progression, alright, of factoring. Oh, can't see it. That's an x. Alright, we started here and we finally finished here. So we started right here. This was the start of the factoring process, and this is where we finally finished. Alright, so hey, factoring is not always easy, but it's definitely doable. Alright, you have a good day.